Hello all. Today's notes are on sum and difference formulas, which is section 5-4 in your textbook. These formulas here, these three formulas, are given on your note sheet as well, so refer to that as we're working. A couple things just to point out before we get started. So this is saying, here's how we can find the sine of two angles added together. So the sine of, let's say, 30 degrees plus 45 degrees. Okay? A few things on here. First of all, for whatever reason, whoever came up with these years ago decided let's use U and V for these angles. So here's some U's and some V's. So this is two different angles. U stands for one angle, V stands for another. Unfortunately, U and V sometimes look like each other, so be very careful when you're writing these, or just rewrite the whole thing as X plus Y, let's say. Second of all, here's something else that's kind of strange. See this plus or minus here? There's also a plus minus over here. See this plus minus here on the left? There's a, hey, this isn't a plus minus, it's a minus plus. And in fact, in this expression, there's a plus minus and a minus plus. Well, what on earth do all those things mean? Let's get this stuff out of the way here. So when you see a plus minus, that means let's say you are deciding to use this formula as U plus V. That means use the sign that's on top, so that means you'd use plus over here. If you're saying U minus V, use the sign on bottom, you'd use a minus over here. With this expression, let's say you said cosine of U plus V, this sign on top, you would then use the sign on top over here, which is the minus. And let's say you did tangent of U plus V, you'd use the sign on top here, which is plus, sign on top here, which is minus. So the plus minus and the minus plus, it's set up in that way because you need to use the appropriate sign depending on how you set up what's on the left. So basically, you're given what's on the left. Either use a plus or a minus. Depending on whether you're using the sign on top or bottom, we need to use the sign on top or bottom over here. Okay, so let's take a look at an example of these. So first example, we need to find the exact value of the sine of 15 degrees. Now, if you type in your calculator sine of 15 degrees, you'll get some strange decimal. If you look on your unit circle, you'll see sine of 15 degrees does not exist, because 15 degrees is not a part of one of those special right triangles from our geometry days. However, we can rewrite 15 as 45 degrees minus 30 degrees. And if we think of it that way, the sine of 45 minus 30 degrees. Now think about those formulas on the previous page. Here's your U, here's your V. We're using the sign on the bottom because it's minus, so let's use the appropriate formula that looks like this. It's the sine of U times the cosine of V minus the cosine of U times the sine of V. Okay, so that tells me this is equal to the sine of 45 degrees times the cosine of 30 degrees minus the cosine of 45 degrees times the sine of 30 degrees. Hey, having a unit circle here will save you a ton of time. Sine of 45 degrees is square root of 2 over 2. Cosine of 30 is square root of 3 over 2 minus the cosine of 45 degrees, which is square root of 2 over 2, times the sine of 30, which is 1/2. Top times the top, bottom times the bottom gives us the square root of 6 over 4 minus the square root of 2 over 4. And then we can, since we have a common denominator, we can put these together. Square root of 6 minus square root of 2 over 4. Careful, we cannot subtract these square roots, so we just leave our answer just as is. And don't even try to simplify that, what's on the denominator. Keep it as is. We cannot simplify any further. Okay, let's try this next one the same kind of way. So this is going to be the cosine of 45 minus 30 degrees. And in this case, our formula from the previous page is the cosine of U times the cosine of V. And now thinking of that plus minus, actually here it's going to be a minus plus, so that's going to be plus the sine of U times the sine of V. Okay, so that's going to give us the cosine of 45 degrees times the cosine of 30 degrees plus the sine of 45 degrees times the sine of 30 degrees. And again, pulling out the unit circle here would be very helpful. This is square root of 2 over 2 times square root of 3 over 2 plus square root of 2 over 2 times 1/2. So that's going to give us the square root of 6 over 4 plus square root of 2 over 4. And again, we will write this as one fraction, square root of 6 plus square root of 2 all over 4. Notice your answer to both of these very similar, okay? And in fact, you'll see these similar kind of expressions for all these. What about this next one, the tangent of 15 degrees? Now, tangent is the most complex of these formulas. It looks like this. Tangent of 15 degrees is the tangent of u plus or minus the tangent of v over 1 minus or plus the tangent of u times the tangent of v. And we're going to say this is the tangent of 45 degrees minus 30 degrees. So u is 45 degrees, v is 30. We're saying minus, we're using the bottom sign. Okay, so let's see what we can do with this. So this is going to be the tangent of 45 degrees, which is 1, minus the tangent of 30 degrees, which is 1 over square root of 3, over 1 plus the tangent of 45 degrees, which is 1 again, times the tangent of 30 degrees, which is 1 over square root of 3. Now this is the correct answer, but we need to simplify this algebraically, and here's where things get messy. So I want to write everything in terms of something over 3. So I'm going to say 3 over 3 minus, rationalizing this denominator, gives us square root of 3 over 3 over 3 over 3 plus square root of 3 over 3. And since everything's over 3, we can write this as 3 minus the square root of 3 over 3 plus the square root of 3. And then we should still rationalize our denominator here by multiplying top and bottom by 3 minus the square root of 3. If we do that, we get on top here, we get 9 minus 6 square root of 3. Oh, wait, yep, 6 square root of 3 plus square root of 3 times square root of 3, which is 3. Over on bottom, we get 9. The middle terms cancel. Minus 3, so we get just, going to have just 6 on the bottom. So bringing that over here, we have 6 in the denominator. On top, we have 12 minus 6 square root of 3. And let's divide everything by 6, which gives us 2 minus the square root of 3. Hard to believe all that work would give us a relatively simple expression for our answer. Okay, that's about as tough as things get. Let's take a look at another one of those. So we want to find these exact values, and here we don't have our answers, our initial expression degrees, it's in radians, but we work with it the same way. So we want to find the sine of 5 pi over 12. Here's our big hint. 5 pi over 12 equals 3 pi over 4 minus pi over 3. So here's your u, here's your v. We're going to subtract, so we're going to use the bottom sign in all of our expressions. So this is going to be equal to, looking at that formula, the sine of u times the cosine of v. So I'm going to say the sine of 3 pi over 4 times the cosine of pi over 3. Then thinking of my plus minus sign, I'm going to have minus the cosine of 3 pi over 4 times the sine of pi over 3. So checking out the unit circle, the sine of 3 pi over 4 is going to be negative square root of 2 over 2. Cosine of pi over 3 is going to be square root of 3 over 2. And then let's see here, minus the cosine of 3 pi over 4. Cosine of 3 pi over 4 is minus square root of 2 over 2. And looking at that, I think the sign over here should have been positive, so I'm going to change that. So square root of 2 over 2 minus a negative square root of 2 over 2 times the sine of pi over 3, which is 1/2. Minus a negative gives us a plus. This ends up being square root of 6 plus square root of 2 over 4. Again, very similar to an answer we saw before. In fact, second one is going to end up giving us something similar. So this is going to be the cosine of 3 pi over 4 times the cosine of pi over 3. Now we have to remember how that minus plus works, so that's going to give us plus the sine of 3 pi over 4 times the sine of pi over 3. And I'm going to fast forward just straight to our answer. That gives us minus square root of 2 plus square root of 6 all over 4. Now I do have on here the most difficult of these, the tangent of 5 pi over 12. Now I'm going to show you a shortcut. Tangent equals sine over cosine, right? So we can take those answers we had before. Square root of 2 plus square root of 6 over 4, there's sine, over minus square root of 2 plus square root of 6 over 4, there's cosine. And then since they're both over 4, we can say square root of 2 plus square root of 6 over minus square root of 2 plus square root of 6. We still should rationalize that denominator, but I think you can take it from here. So I'm going to stop there, leave the rest to you for this. But you can do this a couple different ways. Use the formula or think sine over cosine. All right, so let's look at a totally different kind of problem that uses the same formula. So on the previous problem, we were looking for something like the sine of 15 degrees or the sine of 75 degrees. Here we don't know the angle measure, but instead we're saying, let's say sine of some angle equals this, cosine of some angle equals this. What if we added those angles together? Well, to do a problem like this, we need to make a sketch first, because we don't know where those angles are. In fact, our unit circle does not help us here at all, so let's put it aside. Let's sketch both of these. So first of all, I'm going to sketch U. So here's U. It's in quadrant 3. So U looks something like this. The sine of angle U is negative 7 over 25. And I can use the Pythagorean theorem to find that missing side is negative 24. Again, since it's to the left, it must be negative. Here's V. V is also in quadrant 3. The cosine of angle V is negative 4 over 5. And using the Pythagorean theorem, we can find that missing side is negative 3. So angle V is this much right here. Angle U is this much right here. What if we add those angles together? What would the cosine of that new angle be? What if we subtracted those angles? What would the sine of that new angle be? Okay, so let's talk about the first one, cosine of U plus V. Well, pulling this right off of our formula sheet, we get the cosine of U times the cosine of V minus the sine of U times the sine of V. And we can't get these answers off our unit circle, but we can get them off of our sketches. So the cosine of U is negative 24 over 25 times the cosine of V, which is negative 4/5, minus the sine of U, which is negative 7 over 25, times the sine of V, which is negative 3/5. And if we multiply top times the top and bottom times the bottom, we get 96 over 125 minus 21 over 125, which if you subtract those, you get 75 over 125, which simplifies to 3/5. So if we add these two angles together, we'll get a new angle somewhere. The cosine of that new angle will be 3/5. Okay, what if we subtract these angle measures? Okay, let's pull this formula right off of our unit circle as well. Or excuse me, off our formula sheet as well. No unit circle needed at all. That gives us the sine of U times the cosine of V minus the cosine of U times the sine of V. All right, so that's going to be negative 7/25 times negative 4/5 minus negative 24/25 times negative 3/5. And again, those values all come from these two sketches. Okay, so that's going to be equal to, let's see here, 28 over 125 minus, let's see here, 72 over 125, which is equal to negative 44 over 125. And I don't think we can simplify that at all, so I think that's our final answer there. All right, so if we're given an angle measure, like on the previous problem, we use our unit circle. If we're not given an angle measure, we make a couple sketches and use those sketches. So let's look at one more like this. So again, we're going to make a sketch for U and a sketch for V. So it's saying that u is between pi and 3 pi over 2. That's like saying u is in quadrant 3. So I'm going to make a sketch for u. Well, let me start over with that. I don't know what happened there. So u is going to be somewhere down here. There's angle u. Cosine of u is negative 15 over 17, and the Pythagorean theorem tells us the missing side is 8. V, which I'll put down here, V is going to be between 0 and pi over 2. That means quadrant 1. And the sine of V is 4/5. And the Pythagorean theorem tells me the missing side is 3. Okay, so V is this angle right here. U is this angle right here. If we subtract these two angles, what would the sine of that new angle be? Okay, so that's going to be the sine of U times the cosine of V minus the cosine of U times the sine of V. And all of these values we're going to get from our sketches. So looking at the sketches, that gives me negative 8 over 17 times 3/5 minus negative 15 over 17 times 4/5, which is equivalent to negative 24 over 85 plus 60 over 85, which equals 36 over 85. So if we were to subtract these two angles, the sine of that new angle would be 36 over 85. Okay, what if we add these two angles? If we add these two angles, what's the cosine? So that's going to be the cosine of u times the cosine of v minus the sine of u times the sine of v. And again, all these values we'll just get from the triangles on the right. So that's negative 15 over 17 times 3/5 minus negative 8 over 17 times 4/5, which is equivalent to negative 45 over 85 plus 32 over 85, which equals negative 13 over 85. So if we add these angles together, the cosine of that new angle would be negative 13 over 85. Now, one quick warning before we wrap up these notes. Sometimes people get to this point and they say, shouldn't we simplify some of these fractions in here? Well, if you think about it, we're always getting these like denominators down here. So if you simplify up above, you'll have to get a common denominator down here anyway. So don't bother simplifying until you get to the very end. All right, that wraps up these notes. On page 384 are some homework problems I'd like you to practice. When you're done with those, you can move on to your final set of notes for this chapter.